Howdy folks, today we're looking at direct variation. Direct variation. Now hopefully most of you have done direct variation before, otherwise you might need to look up a little bit on this, but I'll try to explain this as fast and as best as I possibly can. For direct variation, you need to remember this formula, y equals kx. Okay, it is essential. Without that formula, you will not know how to do these questions. Now we've dealt with things like y equals mx plus b, so we should know what the y and the x stand for. They're sort of like coordinates, I guess. The k, however, although it looks a bit different, looks like we haven't seen it before. We probably have. Okay, this is what we call the constant of variation. Now, remember, what does constant mean? Constant means the number doesn't change. So basically what that k value is like a multiplier. So for example, if x was 3, so if I put something like this, y equals 3x. So I put the constant of variation as 3. If x was, let's say, 2, y would automatically become 6 because 3 times 2 is 6. Okay, or if x was 4, it'd be 3 times 4 is 12. Okay, so the constant of variation is kind of like the constant multiplier. Now, can you remember what word we often use for another number that looked like that? Hopefully you remember it is kind of like the gradient. Okay, the gradient. Because remember, that's how the gradient works as well, but because we're talking about direct variation, we use a different letter. So it's y equals kx, and that's our general form of direct variation. Now, a lot of people get confused, but how do I know if it's a direct variation question? Well, the question will use a couple of key words in it. One of the main ones is directly varies or directly proportional, or a variation of those two sort of statements. Okay, so often when you come to a question, you'll be able to see very clearly that it's a direct variation type of question. Now we said that our formula is y equals kx. Okay, so we know that. Now, in all our statements we say, or the question will read, y varies with x, or y varies as x. I often draw this little tool because it helps me remember that y varies with x. But sometimes they might say things like y varies with the cube of x. Okay, now when we did y varies with x, we came up with y equals kx. So what might we do with the y varies with the cube of x? Well, it would be y equals the x cubed, because that's the cube of x. If it was y varies with, let's say, the square root of x, then it would be y equals k times the square root of x. Okay, so it just helps us to come up with that formula. So there are a couple of different variations of the direct variation formula, y equals kx, as you can see, but the questions will be very obvious in that. So we're going to look at a couple of questions to start us off. Okay, so for this first question, it reads, the weight of an astronaut on Mars is proportional, wow, it's a very big key word there, proportional, so we know it's direct variation, to his weight on Earth. A 72 kilogram person weighs 27.4 kilograms on Mars. And before we even get to the questions, okay, there's a couple of things I will note. First of all, it says the weight, so the weight is on Mars is proportional to the weight on Earth. So we've got weight on Mars, so Mars is important and Earth is important as well. So often what I write down is this: y varies or is proportional to x. So what was y? Y was the weight of the astronaut on Mars. Okay, so let's put an m there. If I put weight, obviously I've got two different weights there, so or two weights, it wouldn't work out. So I've put an m there for that's the weight of the astronaut on Mars. Varies with the weight of the astronaut on Earth. Okay, so M varies with E. So straight away, I know that my formula should look something like this. We know it's y equals kx, but we're using M for the y, and we're using E for the x. Now you might say, well, why is that really important to write down? The issue is in a little while we'll be substituting some numbers for y and for x, like we do with the equation of a straight line. And sometimes we can get confused about which value to use in the y and the x values. But straight away, when I've got M, I know that's the weight of the person on Mars. I'll know that I'm talking about the 27.4 kilograms. If I'm talking about the weight of the person on Earth, we know it's about the 72 kilograms. So it's very clear to me now where I should put things. And once you do this a few times, you'll start getting the swing of things. Now look, I write that down anytime I see a directly proportional question. That's something I write down straight away. Okay, look, when you're dealing with these questions, they're going to be asking you on a couple of different sort of things. The two main things that they're going to ask you, and this is whether or not they ask you directly. They're going to ask you to find the constant of variation, which remember is that value of the k there, and an equation of variation. They're two things that they're going to ask you to find, or you'll have to find in order to answer any of these questions. Now, we're going to look at question A and just see what they've asked us to find first. It says here, calculate how much a 60 kilogram person weighs on Mars. Now, they haven't spoken at all about a constant of variation. They haven't spoken at all about the equation of variation. However, in order to answer these two questions, it is so much easier if I have that equation of variation. Okay, so what we're going to do, and we should do this every time, we're going to first of all substitute some values into our formula in order to find out the k value. So we know we've got the formula now, m equals k times e, or y equals k times x. Okay, now the weight on Mars, it says weight on Mars here we know is 27.4 kilograms. 27.4 kilograms. Now remember, I'm not using any of the values in the question because we need to find a general equation first of all. So k times, now the weight of the person on Earth was 72 kilograms. Okay, so what we now need to do, and often look, if you guys are in the habit of using your equations mode on your graphics calculator, all for it. Okay, it's just easy to type that in. 27.4 equals your x times 72, and that will give you your value for k. If you don't like using your graphics calculator, then what you need to do, you need to get rid of that times 72 by dividing it by 72. Okay, either way, whether you do it in your graphics calculator or if you do it the long method, you'll get the constant of variation of being approximately, let's say, 0.380, let's say 6. Okay, so 4 decimal places. What I can now do is I'm going to rewrite that into our formula above. And that's what we talk about, the equation of variation. It's just that equation there, but I've now got that constant. I know what that k value is. Now the reason I do it this way, and this is why it's so important, is if I'm given the weight of someone on Mars, then I can just put it where the m is, and I can then find out what e is going to be. Or if I'm given the weight of the person on Earth, I can just chuck it in there, and I can find out what the m is going to be. No matter what they throw at me in my questions, I can now answer it every time. So obviously in this question, they haven't asked us to find that constant of variation, that k value. They haven't asked us to find that equation of variation, but you can see how useful it is every time to do that. Okay, so now let's get to the question. It says, calculate how much a 60 kilogram person weighs on Mars. Well, we're looking for what they weigh on Mars, so that must be the Earth weight. So we've simply got the Mars weight equals 0.3806 times it by the Earth weight, which is 60 kilograms, and that's just a straight calculation in your calculator. So we're just timesing it by 60, we get 22 0.8 kilograms. How easy was that? You know? So that was once you get it, once you got that formula, you just bang it in. The second question says, if an astronaut weighs 32 kilograms of Mars, what's his weight on Earth? Well, you're doing exactly the same thing, but you're putting the 32 where the Mars is, 0.3806, times it by, and it's your Earth, because we don't know what that Earth weight's going to be. That's what we're looking for. Again, if you're using graphics calculator, simply type it in to equations mode and let it solve it. Otherwise, we're doing 32 divided by, because it's opposite of times, divided by the 0.3806. Either way, your Earth weight in this instance is going to be approximately 84.1 kilograms. Okay, how good is that? All right, so you can see again why it's important to start off your question by doing y varies with x. Most people will make a mistake here when they're trying to find their constant of variation, as you saw here, where we put it in as 27.4 equals k times 72. They'll actually put the 72 first because it came there first, but don't get tricked. Always write this method out first, and we'll look at the very similar method for the next question. Okay, I know it probably sounds a little bit confusing to start off with, but trust me, it gets a little bit easier. Okay, so the next question reads, the cost C dollars per kilometer of a running car varies as the cube of the speed. All right, well, first of all, I see that word varies. So it's directly proportional to, directly varies. You know, it's a direct variation question. We've got the cost varies as the cube of the speed. Okay, that's important. Now, either way, the very first thing I'm going to write down, I'm not going to look at the questions just yet. I'm going to write down y equals k times, now it's the cube of x, so x cubed. I'm now going to put in the values that they give me. So the cost varies. So the cost varies with k times, and it's the speed, so the cube of the speed, so it's s cubed. So straight away I've got my my basic formula. I know I haven't put any values in just yet, but I've got that there. So I now know what value to put in. Now, let's go to the question. Notice at the moment, the question so far, well, the statement hasn't got any values in there. So let's go and have a look at the first question. Question A. Write the variation equation. Well, we've just been looking at that. Now, we know the variation equation is the y equals the kx. But often we want to find the constant variation. Now, the only problem here is we haven't been given any values, so we actually can't find the constant of variation. So what they're actually asking for is actually what we've already done here. The y equals kx cubed, but we're putting in the letters that they've used. So we've actually already found it. C equals k times s cubed. You can even put just ks cubed if you want. So that's actually all we can do for the variation equation, because we don't know what that value of k is going to be. We haven't been given any values to start off with. So that more than likely means in question B, they're going to give us those values. So let's have a look. If it costs $1.25 per kilometer, straight away cost is $1.25. Let's write that down. So it costs $1.25 per kilometer to run the car when it's traveling at a speed, there's our S, our speed of 60 kilometers per hour. So 60, and it's cubed. Calculate the constant of variation. Now this time they're asking for the constant. They're asking for that k value. So what you can see as I'm going through that, I've put in my cost, because I've already got that in the equation. It's 1.25. We know that we're looking for the k, and we've got the 60 cubed. Again, if you're using graphics calculator, let's just bang it out on the equations mode. Okay, it's just 1.25 equals x times 60 cubed equals, and let it solve it. If you're not using graphics calculator, okay, well, we're dividing it by the 60 cubed. Now obviously we're dividing by a huge number there, so it's going to be a really small number. Now it says there 4 decimal places in standard form. So remember, standard form means times 10 to the power of. If you do it in your calculator, it should come up with that standard form automatically anyway. So if we do that correctly, we're going to get k equals 5.787 times 10 to the negative 6. Okay. Alright, so we've got that there. Now, we've done part B, so last of all now it says part C, hence calculate the cost of running the car when it travels 85 kilometers. Okay, well we haven't rewritten the formula yet with that k value in, so let's write that down. C equals our 5.787 e negative 6 times s cubed. Now, you might have asked why I put e negative 6. Well, remember, e means simply times 10 to the power of, and I just wanted to save a bit of room and a bit of time. So that's our actual formula. It's a bit more advanced than the first formula we wrote in because we had that k value in. And now all we need to do is substitute that 85 kilometers per hour, which was the speed. So it says calculate the cost. So cost equals 5.787 times 10 to the power of negative 6 times, and it's 85 cubed. And all I need to do is put that in my graphics calculator or my normal calculator and do a straight multiplication, and we get a cost of approximately $3.55. Okay, they could have told us what speed of my car would it be if it cost me $20, and so all I'd have to do is put the 20 where the C would be and then put it in my graphics calculator. So again, you can see no matter if they ask you, in this case they did ask you for the variation equation, the constant variation, if they don't ask you, you still got to do it because it makes it so much easier in the long run. Look, there's a lot of food for thought here. Go into your textbook, get some questions out, keep on going over it, focus on writing down the y equals kx, then substituting in the values that they've given in the question, or the words, the letters. Get that out, find your constant variation, find your equation or variation equation, and then have a crack at doing the questions. Okay, please make sure you ask if you need some assistance, guys. If this is confusing, let me know and I'll try to make an easier version of it.